Hello, and welcome back to Low Nachos. With the school year starting up for many parents and kids, one of the things I'd like to discuss or review from our last school year is the microbit platform that my kids and I have seemed to enjoy. Pull a picture here. So this is their homepage. I actually found out about microbit from a Make magazine sometime last year. I think I was on a flight and grabbed a magazine or so to pass the time. And it seemed interesting to look into it. It's fairly low cost platform. It's about $23. I actually acquired it via a gift exchange last year, so whoever got this for me, Secret Santa, thank you. So the microbit's a embedded platform. It's off the shelf, ready to go out of the box, plug and go, pretty much. And the nice thing about it is that it works really well with homeschooling or this enrichment or extracurricular. They do include several curriculums to go over that you may use with your children. I end up using they've revamped the site recently, so it looks different than what I'm used to. But the one it's still here is the Intro to CS, Intro to Computer Science course. Now it says ages 6 to 8, age 11 to 14, but don't be limited by those age ranges. If your kids can understand concepts and find it as a gainful experience, certainly do so. And the nice thing about this is that this program has a it's not just programming. It goes into the life cycles of software development, or product development. They have example exercises for the students to work together, or the kids to work together, to capture requirements or voice of customer, and then reinforce some design, sketch up, mock up, and then actually develop and test. I think I have some pictures here of so one of the lessons was in the CS course lessons is one of them was making a pet. So if I remember correctly, the exercise was to have the students collaborate with each other and say, what kind of virtual pet would you like, and ask questions like size, color, you wanted to do. So there's an example where where the two kids talked about what they would want or what they'd like to have designed, and then here's an action shot of them actually designing the software portion of it. I will say that we'll get a little bit into the graphical programming, but it's pretty nice that it introduces programming in a very approachable manner. And it's web based, and as you can see in this Chromebook, it doesn't require that much computing power to do so. And the end results was that one of the kids wanted a small pet, multicolored was one of the requirements I recall, and the other kid wanted a cat, and so they made a box and there's a tail to represent the cat. So as I said, the platform is about $23. I can certainly show you the copy that I have here. It just comes in a two-sided board. Well, first of all, those are two sides. So one side's got a matrix of LEDs and 2 buttons. And if we flip it to the other side, we have the microprocessor, some connectors for micro USB, optional power on the right there, another button which I think is a reset, I'm not sure, I don't remember. One of the other features on this board, this platform is a Nordic NRF 51 based for engineers out there, and it does have Bluetooth, so there is a Bluetooth mobile application based way to do this as well, which I haven't explored yet. But we can go ahead and plug them in. Plug them all the way. Okay, so I get some thinking. Alright, so there's a program left over from the last time the kids used this. So it powers on, press the button, it turns to a happy face. Press the other button, turns into a sad face. And I don't remember if I shake it, does it do something. If I tilt it, yeah. So if I tilt it, it changes into another pictogram. So I'll leave this here. Come back to the machine view. Now I'll demonstrate here the programming environment, if you will. If you go to microbit.org, there's a Let's Code, and there's several environments. We went with the easy one, the JavaScript blocks editor. I think it's Let's Code, and it's drag and drop once it loads. So there's two. By default, gives you two handles, if you will, on start and forever. So if you're familiar with computer science or any sort of software development, these are events. So you have what you want to do when you initialize the board, and forever would be like your while one loop. You're spinning while one forever. So let's say on start, and so the nice thing about this environment is that it gives you a simulation of the board, and you have all your controls and functions in the middle pane here, and of course on the right is your code area, if you will. So let's say we can basic. Here we are, basic. Let's say if on start we want to show an icon. I can click it in here. There we are. And these are pre-populated pictures supported by the environment. We can start with the on start. We do a heart. Alright. And then let's say what do we want to do in our forever loop? So if we explore a bit more on the panel, there is, of course, there was the basic that just showed up. It does strings, it does delays, inputs. So inputs correspond to the hardware sensing, hardware feedback that's available. So there's buttons, there's a shaker. So if on shake, you can do something else, which I won't use right now. I don't think I won't use right now. Delete, yeah. And they have other options as well if you want to play music or other logic controls. Also math, so you can do some algorithm, do some arithmetic. Let's keep it simple just for sake of demonstration here. Let's say if I want to do something with the buttons pushed. If button A is pushed, where does it go here? This is a different control loop unlock. So I want I think it's this. I think this is the events one. Is it? It's been a while since I've done this. Or maybe this is maybe the event doesn't go into the while loop. It's interrupt. Maybe that's it. So if button A is pressed, we'll show another picture. Let's go with the happy face. So, and if and let's say the other button's pushed, there's a on button be pushed. We can say let's say we're going to do a custom display. Of course, there's many other functions you can do, but we'll just keep it simple for now. Colorize your matrix the way you'd like. Put 2 from each corner. And let's say we're happy with this. Let's say we're happy with our program for now. I have to crawl here for a moment. So the website's got a download button. If I download the hex file, alright, so it's giving me a dialog to save the file. I'll just save it to my desktop for now. So save. I'll roll them up. And the nice thing about the micro:bit platform is that when you plug it into the computer, it shows up as a flash drive. And I'm just going to find out that program here. Now, if I remember correctly, the one of the debuggers, Sager, I think it's Seeger, J-Link's got a it's got a module that's available for system designers to incorporate, where you plug the target in, it shows up as a flash drive, and then once you download the copy of the hex file in, he goes on and he updates the target as if we had a programmer installed, but it's on board. So the light stopped blinking. So on power up, use a heart. If I press the A button, it shows up the happy face. And if I press the B button, it gives me that custom layout that I put together for you guys. Hope you guys found this useful, and potentially use this Explorer and the micro:bit platform to teach your kids about computer science.